All right, let's try making a real personality chip. So I got this in the mail today. This is from OSHPark. OSHPark is a company that will manufacture PCBs in low quantities. So you can design a PCB, upload the design files called Gerber files, or maybe they're Gerber files. I don't know if I've heard anybody pronounce it, but I'm going to say Gerber files. And it takes those and sends them off to a place that will take those files and turn them into PCBs. They'll make 3 of them, or I don't know if it's 3. I think they'll make 3 of them and then ship them to you for not a lot of money. So I uploaded the PCB design I have. This my personality chip PCB design here, and I also made it available so anybody can go on OSHPark and order the same PCB, and I'll put a link in the description. So I want to use the OSHPark PCB for this demo here because this is the same thing that you would be going through if you try to make one yourself. So let's see how these things turned out. I have no idea. This is the first time I've ever ordered an item, a PCB to get manufactured from OSHPark. I have no idea what this is going to be like, and I'm kind of curious. Up until now, I've only used jlcpcb.com and PCBway.com. This is something new, and we have first, a sticker. Cool. I'll stick that somewhere later. 1, 2, 3 PCBs. That's it. That's all that's in there. Alright, so let's take a quick look real quick here. This is kind of interesting how when they make these PCBs, they panelize them, meaning there's one big sheet of material with a bunch of different PCBs on it, and then they go in with like a router and clean out bits around, carve out the edges of your design, and then they cut out the edges of the other PCBs from that other people have on the same big sheet that yours are in, and except for these little stems here to keep everything sort of together, so they can still carry it around as one big sheet instead of carrying around a bunch of tiny little PCBs. And when I order from PCBway and JLC PCB, the edges are smooth. They're not the little stems, thorns. I don't know what you want to call them. They're still here on this one, which, I don't know, that's kind of annoying. Especially the one on the bottom here. That's going to get in the way when you insert it into the chip reader there. But the finish is nice. The finish looks like it's got a gold deposit finish. That apparently is standard for OSHPark. For PCBway and JLC PCB, it's just it's regular. It's just basically a tin alloy over copper, and you have to pay a lot extra. To get the gold finish like this, but that comes. I should point out right now, this cost me $4 to get these 3 things made. So price-wise, that's exceptional. It took maybe a week and a half from order to these being in my mailbox. So in terms of the quality, the silk screen, that looks pretty good. I mean, yeah, I'm happy with how that came out. I just wish the little, again, I don't know what you want to call them, thorns. I think I'm going to call them thorns. Those are a little annoying, but yeah, other than that, I'm happy with how these came out. So how do we get rid of those? I have no idea. Let's try a couple of different things here. We can try a hobby knife real quick. Let's see if I can just saw right through it. Yeah, I guess so. And then Yeah, maybe that'll do it. Or I could probably get some, maybe some sandpaper and sand those edges up. What about these side cutters that you use to, well, that I use to like cut leads off of components, through-hole components? Yeah, it gets them a little less pointy, but yeah, this is one of those things where I think maybe coming with the side cutters as a first pass, and then you're going to need, I don't know, sandpaper or a file. I think I have a file somewhere. Well, hang on a sec. Yeah, I got these that I don't know where I got this little set of files. I think I just got it at like a home center, probably on clearance or something. So the little thorn on the bottom, that's the one that I want to get rid of. Is this gonna do the job? I think so. Yeah, I think that'll be fine. I mean, I could sit here and, you know, really meticulously try to file that nub away. But yeah, that's fine. That'll work fine. And then the little thorns on the edges here, I'll go around on this one at least, and I'm gonna clean them up real quick. But I mean, for a small batch of just a few, like, so if you order 3, I think 3 is the minimum order. If you were to order one of these from OSHPark, you know, filing these things down, or sandpaper, or you could probably even just take a again, like a hobby knife, and just sort of maybe scrape it away a little bit like that. But you know, I'm trying to figure out what the cheapest options here are to get rid of those things. Like, I don't want you to have to go out and buy, you know, a set of tiny files just for this stupid thing. But okay, I'm gonna go finish cleaning those off, and then we'll have to talk about building it. I only spent, you know, a few minutes on it. You can see there's still a little bit of a bump there. But yeah, that's certainly good enough for what we'll be doing. So the next step now is to get the components that we need to build this up. The first thing we have to talk about is the memory chip itself that you're going to use here. The personality chip here supports both a surface mount SOIC 8 format or package chip and a DIP dual inline package 8-pin chip. You pick one of those packages, doesn't matter which one, because it supports both. So let me show you. Oh, that one's sealed up. I'm going to grab this one that's opened, and I'll show you. SPI flash chips. There are websites like mouser.com, digikey.com that sell all sorts of electronic components. I'll include a list of links to, I think, Mouser, because I've bought everything from Mouser. So I'd rather share links to places that I've already bought. Like these came from Mouser. Or Mouser. I'm not sure how the pronunciation is. But open this thing up. And this is how they came. And here is an example of a DIP or dual inline package. It's just 2 rows, dual inline, 2 rows of 4 pins. That is a, let me show you, that is a WinBond 25Q32. So you take the number after the Q here, divide it by 8, and that's how many megabytes this thing can hold. So that's 4 megabytes on this chip here. And stock personality chips that you buy at Droid Depot, those are 1 megabyte chips. So, and the size doesn't really matter here. It's a limitation on how much audio you can put on the chip. You do not have to have a 4 megabyte or a 1 megabyte. Any size will work. Here's a small outline integrated. I don't know what SOIC is. SOP is small outline package, I think, 8 pins. And this is, if it wants to focus, a WinBond Does it say 16? I believe it does. So this is a 2 megabyte chip, whereas the through-hole one is a 4 megabyte chip. So why would you pick one over the other? Personal preference, really, and maybe cost. I forget which one is cheaper. I think these are cheaper, but I'm not certain. The other factors in which one you choose might be what equipment you have available to program these things with. So, for example, with these SOIC or SOP8 packages, most programmers, do I have one handy? Sure. Here is one of the programmers that I use. This is a TL8662 Plus. And you'll see that these programmers, or even the cheaper one, like there's a USB-based one, it's what is it, CH341A or 314A. They have these things, they're called ZIF sockets, zero insertion force sockets. The idea is you can take your chip, put it in there, and then lock it in place. So you don't have to force the chip in there. So most of these programmers have this style of socket, this ZIF socket, which means these tiny little chips, they're not going to fit in there. You need an adapter. So here we have a socket adapter. In fact, I have two here. And you're going to see, I hope, if I've done this right, which I haven't. So forget the other one. You can see this one says 150 mil. So they come in 150 mil and 208 mil or 220 mil sizes. If you buy a programmer like this, they usually come with a bunch of different sockets, so you don't have to worry about this. But if you're going with these smaller ones, you need one of these sockets, and then you gotta go through the process of lining up the chip, so make sure the orientation is in the right way. There's a little dot or a little dimple on the surface of the chip. All right, focus. There you go, right there. That signifies pin 1. When you look at the programmer, there's a symbol of a chip with a dimple. That tells you where pin 1 should go. So pin 1 should go over here. So if I'm inserting this socket in, like so, pin 1 needs to be over here. So we got to take some great care here in getting this chip into the socket. You push the socket down, lay the chip in place. Come on, there you go. And I like to give it a gentle pull to make sure there's a good connection to the pins. And there you go. Now you can stick that in here, close it up, hook it up, and you're ready to program this chip. That seems like a terrible amount of fidgeting, and if you don't want to deal with any of that, which I totally understand, having one of these dip pins or dip memory chips is way easier. Look at that. Whoops. They just like to pop out, so be careful. What else is worth considering? So let's say you want to reprogram this chip, which you will probably want to at some point. With the through-hole chips, you can also go and get a socket. And I've just dumped a bunch out. So instead of just putting a chip, the big dip chip on here, I could put a socket in here, like so, put that in place. The chip just sort of, it's just a friction fit. You just stick it in there and it holds itself in place there. And then if you want to reprogram it, you take the chip out of the socket, very easy. Put it into the programmer, program it, stick it back in the socket, and you're ready to go. If you have a surface mount chip, like this here, it's soldered to the board. They do make sockets for those, but they're very expensive and hard to find. You're probably not going to be using a socket for one of those. So instead, you have to, if you want to reprogram it, you need, well, let me see if I can find it. Yes, I found it. You need one of these. These are clips that clip onto the chip. And the other end here has a little ribbon cable that plugs into these pins, so then you could put it into your programmer like that. So you put that into your program, and then you take your personality chip, you line up pin 1. Pin 1 is this red or pink colored wire here. You just want to kind of clip it in like so. And now you're ready to program your chip. So pick your poison on what you feel most comfortable with. In my head, the best option, actually there is no best option, it's up to you. This is smaller, this is the surface mount chips. You could put a clip or a cover over this much more easily, and it's less bulky, versus, again, one of these with a memory chip in it, with the through-hole memory chip and the socket and everything. You can see it's much thicker, there's more bulk to it. But it's easier to get the chip in and out and program it. Also, while I was looking around for that clip, here's the other programmer I was talking about. This is the CH341A. It says Pro here, but they're all the same basically. This can be bought on Amazon right now for like $10, and it will come with one of these clips. This programmer costs about $60. It can cost way more than that, depending on where you buy it from. Prices vary wildly. I mean, it can cost you as much as $100 or as little as $50. You just got to dig around and find the best place or the best price. I find eBay has the best prices for these. Amazon is usually $10-20 more expensive. But both of these usually come with potential add-ons like the sockets and whatnot. But again, for $10, you can get one of these with the little clip that I just showed you. Why the big price difference? This supports, as you can see, bigger chips, more chips. It can do more than just memory chips. It can do microcontrollers and it can test old TTL logic chips and all sorts of stuff. This thing has a lot more versatility to it. So if you want to do stuff more than just programming flash chips, this is the one to go with. But if you're just doing personality chips, you don't really care about anything else, this is your best, cheapest option out there. Also, while I was looking around, I found that other socket, the 200mm socket. So you can see it's just a little bit bigger or a little bit wider. When it comes to this chip here, this is designed for the smaller chips, the 150mm chips, but I believe, and we'll test it right now, if I can get the chip out. Come on. I believe the bigger chip should fit. It's just going to be a little bit more of an adventure to get it on there. So if I just line it up, yeah, it would fit. But I mean, it goes right to the edges of the pads. Let me zoom in for you. So you can see there are the pads there, and you can see it just barely fits. And you could definitely get in there with solder and get those connections all lined up, but it's going to be a little bit of a headache, which is why I would go with the smaller chips. And again, I'll have links for both the surface mount chip here that I am using and the through-hole chips where you can buy them on Mouser. They're like 50 cents a piece, I think. You'll see. Okay. That takes care of discussion about the memory chip itself. Oh, there it is. There's the surface mount chip. I think for our sake, I'm going to go with the surface mount chip for this demonstration. Again, either approach works fine. Don't worry about it. It doesn't matter. One is not better than the other one. Through hole versus the smaller one. Okay. So besides the memory chip, once you have your memory chip and your PCB picked out, you still have a few more passive components to populate here. Okay, so we have on the front here, we have two capacitors. They begin with the letter C, so you know that they're capacitors, and you have a resistor. You know that's a resistor. It begins with the letter R, the designation markers here. And on the back, there is a second resistor here. So we have two resistors, two capacitors. The two resistors are both the same value. They are 10,000 kiloohms. They are used to pull pins on the memory chip low to the ground or up to the power rail. So they either bring the voltage on that pin down to 0 or up to what will be 3.3 volts coming into this chip, just to tell the chip this feature should be turned on or off all the time. They don't have to be 10,000 ohms or 10 kiloohms or 10K resistors. They could be slightly lower values. Maybe they could be slightly higher values. The only reason for changing the value is you might be running a little more current through the chip if it goes through a lower value. Like if it was 5K instead of 10K, you'd be running a little extra current through the chip, and the chip might get a little bit warmer. But don't worry about it. I just stick with the 10K. The only reason to not use 10K is if that's not what you have on hand. Oh, and then for the capacitors, we have two capacitors here. C42, that's called it can be considered a power supply capacitor. It could also be called a bypass capacitor. It's basically a little reservoir of electricity, so that little transients that cause a dip or a spike in current sort of get soaked up by that capacitor and don't impact the chip. C44 is a bypass capacitor. It's going to let very high frequency noise pass through it. Capacitors have their nature is to let changes in voltage pass through them, if that's the best way to think of it. So if you have noise, ambient noise, electrical noise being conducted into the chip, you might get a spike of voltage come through, and it's going to disrupt how the chip operates. But this capacitor is going to let that spike pass through it. Instead of going into the chip, it'll pass through it to ground. That's what that one is for. So C42 usually around 100 nanofarads or 0.1 microfarad. You can fudge that number a bit, and you're not going to be causing too much of a problem. C44 is interesting. C44 is connected to the clock pin on the chip. The clock pin, by its nature, is a high-frequency line. So you need a capacitor that's very, very small. So it's going to only allow very, very fast noise to pass through it, but sort of medium fast noise, which is going to actually just be the clock signal. You don't want it to let it pass through. So you need a very small value. So stock chips, it's usually about 2 to 3 picofarad. I've gone with 15 picofarad, and I'll explain why in a minute. 15 picofarad works fine. You could probably get away with something a little bit bigger, but once you go up to like 1 nanofarad, it stops working and it breaks the thing. You can get away with not using a capacitor there at all, but then you run the risk of your chip acting a little funny from any electrical noise passing through it. Okay, so why 15 picofarad? Why did I use that? Very simple. This is my source for all of these things. This is a sample book that I bought off of eBay a while ago. And I should explain the size of the resistors and the capacitors are 0805. That is a code in inches and millionths of an inch, so 8 millionths of an inch by 5 millionths of an inch. It's a standard size for surface mount components. This book, again, I got this off of eBay. You can just search for sample book and then the name of whatever you want. 0805 resistors, 0805 capacitors, and you'll find these. They usually cost like $20-$30. This book came with resistors and capacitors of different sizes. So why did I go with 15 picofarad? Because in the capacitor section, which begins here, the smallest value I have is 15 picofarad. So that's why I used 15 picofarad. I was very happy to discover that it worked. So we need 2 resistors of 10 kiloohms. So we can see 8K, 6K, 5K, 10K, 10 kilo ohm resistors. Okay, so I'll just come in here. You can tell how common of a value that is because in this book here, it came with like 4 or 5 strips of that, whereas some of the other values that are less used, there's only 1 or 2 strips. So there are my two 0805 10K resistors. Put those off to the side. Next, I need that 15 picofarad capacitor. Not a very common value. You can see I only got 1 strip of those. You don't have to buy these in a book. You can buy for like 10 cents a pop individual ones of these if you want. I'll include links to Mauser where you can buy one of them, you can buy 100 of them, you can buy a whole reel, and it'll cost you a couple $100, but you'll have tens of thousands of them if you want. That I'm going to also place, because I'm going to have 2 capacitors of different sizes, but they're going to look exactly the same. There's no markings on the capacitors. It's very easy to confuse which is which. So the small one I'm going to stick way off to the side, so that way I know that that is the small capacitor. Now I need the power supply capacitor here. This is 100 nanofarads, 470, 100 nanofarads. Again, very popular value, very common. This book came with several of them, so I'll just clip one out like so. Put that over there. I have all the components now that I need to make this chip. So my goodness, it's about time. Let's start soldering. Interesting conundrum. What do you solder first? It's up to you. You can go in whatever order you want. The only recommendation I would have is the front with the memory chip. Do all of that first before you put the lone resistor on the back. Otherwise, that resistor will be sitting there flapping around if you're doing this on the table, and that'll get a little bit annoying. Or you could have like a little vise or something to sort of hold it up in place, and then you don't have to worry about it, and you can go in any order you want. After that, when you're soldering surface mount components on a PCB like this, general rule of thumb is work from the middle out. So we're going to start with the main chip here. So another question: do I program the chip now using the socket, or do I program it later? I could do both, or I could do either one. It's whatever is easiest for you. It doesn't matter. For demonstration purposes, I'm going to wait until after I've put everything on the PCB, just to show you that it can be programmed. The surface mount can be programmed when it's still connected to, when it's soldered to this PCB. So what I'm putting down now is this is a Flux pen from Chip Quick. It's just a tube of chemicals, flux, that will help the solder flow better on the PCB. Not 100% necessary, but it does make life a little easier. But again, you do not need it. All right, so what do we want to do? I want to solder now. First thing I'm going to do is I'm going to pre-tin. I'm going to solder one of these pins here. Then I'll put the chip on, reflow that solder for that that pin. That'll hold the chip in place. Then I can go and get all the other pins. The top right pin, that is a ground pin. That means it's going to take a lot of extra heat to heat up the pad there for the solder to melt. I am not going to use that as my pin to solder or pre-tin before I put the chip down. I'm going to use this other one here, the one for pin 1. So just put the soldering iron down. Little dab of solder there. Perfect. Now I bring in my chip, and there is no beauty contest going on here. It doesn't need to look perfect. It doesn't need to be centered perfect. As long as you've got a good electrical connection, it will be fine. I'm going to reflow that joint one more time just to make sure the chip is flat against the PCB. That looks good. Again, I'm going to come back in. Is that in focus? Close enough. Put more flux down so I get some flux on the pins of the chip itself. And now I'm going to let the flux and the solder work its own magic. I'm going to try a little something here called drag soldering. You'll see in a second. I'm just going to put a big blob on pin 8 here and then just drag the whole thing down. Surface tension and flux will do all the magic. In theory, I could also be talking complete crap here, which is what I think I've just been discovered as doing. Yep. Why is that pin? Why? It's sort of working now. But there's too much solder there. And we can see that if this thing wants to focus, all of those pins are bridged. Well, that's a bummer. Well, now I could sit here and try and, pick a little bit of it off at a time with my soldering iron. That is going to get old very quickly, though. So I could either use soldering flux. I could either use soldering wick, desoldering braid, desoldering wick, whatever you want to call it, or a desolder pump just to suck up the excess. I'm going to use wick here, or braid, whatever you want to call it. Both names apply, I think. And it's just copper braid with a little extra flux on it. Apply heat, and the solder will want to go into the braid and away from whatever you've put it on. So if I just do that, give it a minute to work its magic. Oh, there we go. I wasn't making contact. I gotta pull it away while it's still hot. There we go. I'll retouch all those pins. Again, this is a terrible soldering job. But maybe that's a good thing, because it shows you that you can be a complete screw-up and it still, focus, will work. Yep, so all those pins are connected. That's really all I care about. Again, this is not a beauty contest. You can see I got a little extra solder on those capacitor pads there. That is okay. Not a big deal. We can deal with that. I could wick it away with a solder wick, or we could just leave it and use it to our advantage. Yeah, you can see that pin, that chip is way off. Those pins are not centered on the pads. Again, that's okay. So on this side, I failed so horribly with the drag soldering. Let's add a little solder to the tip here, because I think that might be part of my problem. Wipe it off, just sort of get the tip looking a little shiny again, and now I'll just do pin by pin. So heat, this is the ground pin that's going to take a little extra heat. Come on. Yeah, good enough. And I still have some solder left over on my iron that it flowed off of that onto the other pins without me doing anything. I could leave it like that. I could add a little extra solder. I can't really see. The lighting is atrocious. The camera is in the way. So we'll just take a guess. Bring it back up here. And again, it is not pretty, but it has formed electrical connections. That is all I care about. Okay. What's next? Let's do the clock capacitor, the one that's way off to the side here. This is the focus there. This is the 15 picofarad capacitor, very tiny. And there's already some solder on one of those pads. Maybe I'll add a little more, like so. I'll bring in the capacitor with some tweezers. Reflow the solder that's on the pad, and that's one side connected. I'll just do the same for the other side. Come on. Again, because they're capacitors, one end is going to be to ground and it'll require a little extra time on the soldering iron. And again, that is not straight. That looks awful, but a mechanical and electrical connection has been formed. That's all that matters. Beauty is not an important part of what's going on here. So we'll keep going on now. Depth perception becoming a problem. This is the other capacitor, the 100 nanofarad capacitor. There are other ways that you could put these components onto it. There is a thing called solder paste. It is basically solder in a more liquid form. It's actually lots of very tiny microscopic balls of solder in like a flux pasty like solution, and you can just take like the tip of a toothpick, put a little glob on each pad, and then you can just bring in some heat, put your components in place over the solder paste, and then heat the thing up. The solder melts, and surface tension will orient the components so that they all line up perfectly. And it's like magic. And I'm not doing it for this one, and the only reason is I have to fiddle around with the solder paste, then I got to break out the hot air gun that I have, or the reflow station, I think is what it's technically called. I just call it a hot air gun though, because it's a thing that shoots out hot air at 300 degrees Celsius. That must be a pull down resistor, because that pad needs to heat up. Bring in the resistor. That too needs to heat up a little bit. Put the tweezers on top and reflow it again. I do that just so that way I know that the component is being pushed up against the board. That looks fine. One more. Come on. Now, how does that look? Fine. Again, you can see the edges of the components, the blobs of solder there. It's just too much solder. Look at that. There's a messy. Got a little bit on that pad there. Again, this is not a professional looking job, but that is okay. And that's, I think, the most important thing to learn from this, is that it doesn't need to look good to work. I did a horrible thing earlier, which is I hit the screen with my finger to focus the camera, and now it has automatically put itself into manual focus, so it will not autofocus anymore. So that is why I have to keep taking a moment to readjust the camera. Oh joy. Alright, so here's the resistor on the back. Again, another 10K resistor. Not a big deal, just like before. But as you can see, I'm also having trouble here because the front side is a little uneven because of the components that are on it now. So it's wiggling a little bit like this. And I need to either bring my hand in to hold it, or I could get a vise or something to hold it for me. But anyways, that is the chip. That is everything soldered together. You can see, if I focus this again, that there's like shiny blobs of shininess. It looks like liquid got spilled all over the place. That's the flux. that washes off with rubbing alcohol. So not a big deal. You don't even have to get rid of it if you don't want to. It's not conductive. It's not going to harm anything if it gets left behind. So for now, I'm not going to clean it up. But actually, because I'm going to program that chip, I probably should clean it up a little bit. So I'll show you that real quick. All right, chip. Take a Q-tip, give it a little soak in rubbing alcohol, and just start going to town. The idea here is that the rubbing alcohol is going to dissolve the flux. What it's not going to do is make the flux magically disappear. It's just dissolving it, so now you can soak it up with the other end of the Q-tip. If you didn't do that, then you just get like a dull sheen across the whole PCB, because now all you did is spread the flux out across the whole PCB instead of the concentrated places where it was originally. There we go. That is a clean looking chip-ish. Time to program it. So now begins an interesting exercise in trying to show you both this programmer and the screen. So the programmer I'm going to use is the CH341A here. And the reason I want to use this is it's just the cheap version, and it's probably what a lot of people are going to use. The first thing to note is down here, 25XX and 24XX. That was that junk? Never mind. 24 chips go on this side, 25 chips go on that side. What are we using? Well, if you look at the chip you've got, you can see it begins with 25. So we've got a 25 chip here. So the 25 chip is going in here with pin 1 pointing out towards this little lever here. Keep that in mind. So I'm going to plug it in like so. I'm going to now clip this to the chip. Remember, pin 1 is that red wire there, and pin 1 on here is marked by that little dot. All right. And then I will just leave that in a shot. Pin 1 on the board here is marked. Remember, pin 25 chips go on this half, the half on this side, with pin 1 facing away. You really want to make sure you get this done right. There we go. We are plugged in. Okay, great. So now the first thing I'm going to do, I have on my screen here, I have the ROM, the custom ROM that I've already made, loaded up and ready to go. The first thing I want to do is I want to click this detect button here. Hopefully it will detect there is a chip there. And it did. It figured out immediately that this is a W25Q16. But it also removed the image that I had loaded in memory. Okay, well, I'll have to do that. One thing to note, if you have a type of chip that isn't recognized, that's okay, because this is going to use generic commands that are used for basically every SPI flash chip that's out there. All you need to do, the important part, is make sure you get a chip of the same size selected. So let's say you had this WinBond 25Q16V, right? But it's not detecting it. That's okay. Pick another type. Doesn't matter. And just make sure it's a... Oh, actually, you know what? Let's not go with that. No, let's go with Micron. Do we have Micron in here? What do we know? Doesn't really matter, does it? Common. Maybe common. Yeah, see? And I have a 25Q16, so I'll just select 25X16 here. The Q, the letter there is different between manufacturers. That's why they have an X here. It can be any letter. So 25X16, because I have a 25Q16 here, and now I could load the file, and it would burn it, and it would be fine. In fact, I'll do that. Why not? So I have to open up my memory, my personality chip again, And now it's just a matter of hitting the program button. And sit back and watch the lower left-hand corner as it shows you a percentage of its operation. Very exciting. Now, obviously, if I had used the 4 megabyte chip, this would probably take twice as long. And we're done. Now we can do a cool thing. I'm going to hit detect now. I'm going to hit read. I'm going to have it read the chip's contents back. Really, all I'm looking for here is those first 5 characters. I want to see a GP, right, underscore SP F something something, right? I forget. You'll see it in a second. And if I see that, there you go. GP underscore SPI FI. GP, General Plus, that's the company that makes the audio chip. This is an SPI flash interface, right? So SPI FI. At least that's what I think those letters mean. It's there. I see it. It read it back from the chip. The chip has been written to. It's been programmed. It's time to put it into a droid and see what happens. Very shadowy figure. But it's time to see how this works. So I'm going to turn this on. And to start with, I'm just going to leave this off in case something explodes. Here we go. Chip is going in. Chip is in. Yeah! Yeah. That's my little Easter egg. Well, now let's see the whole thing in action, right? Where's the marker to line it up? There you are. There's your face. That's okay. Actually, the shadow's going to help. So now we can see the LEDs lighting up. Here we go. I would call the personality chip a success. Lesson learned in that higher pitched noises are going to going to make the LEDs respond better. But, you know, for a first go for a proper personality chip, I am okay with that. Oh, and the other thing, of course, this chip can go, has fingers on both sides. It can flip around either way, and it'll work fine. Of course, you're going to play the really high-pitched one just as I take the head off. Yeah, interesting. Anyways, this video is going to be very long, even if I try and edit it down a little bit, because I want to show the whole build process. I want everybody to see exactly everything that I experienced and how it went. You know, I know in a lot of YouTube videos, the build montages are just a little bit of music and 30 seconds of clips, but that's not very useful when you want to learn how to actually put the whole thing together. Okay, so I think that's going to work. If you order some of those PCBs and you make one, I would love to, at the very least, hear about it. Pictures or video would be even better. You can either reach me through the comments or through Twitter. I am at Ruth Sarian, just like the name of the channel here. And yeah, I definitely would love to see anybody else who makes one of these. I want to see how it turns out. I want to hear how it turns out. Good luck. Happy hacking.